Here we start with a simple disease spread model. We can set some basic parameters such as the height and the width of a grid and the infectious period of any square within that grid. If I just start it with a height of 20, a width of 20 and an infectious period of 10, you'll see we get a grid of 20 by 20. I can start the infection by clicking on any square to infect it. If a square is infected, there is a probability that any of the adjacent squares will become infected within the next 10 days, after which the initial square becomes immune. And you will see the color changes from uninfected to infected to immune. If I start now just by clicking on a square near the middle, you'll see how this disease spreads across the grid. And you'll see there are sometimes just little squares which end up staying uninfected. If I restart this with exactly the same parameters and draw the same grid and start in the same place, you'll see that the spread differs this time, and now a completely different square remains uninfected. For a third time, I run the same simulation, start near the middle again, and you'll see the spread pattern is this time different, and just one square escapes infection. If I change the infectious period to a shorter time, so let's say 5 days, and rerun the simulation, you'll see the spread pattern is different, and this time a number of squares remain uninfected. I can do the same again with the infectious period of 5 days, redraw the grid and click on the same starting square, and once again a different set of squares remain uninfected. And we do this just one more time. Infection period of 5, start near the middle, and again we get a different pattern. We can run the same simulation, but this time try infecting a square near the edge of the grid. And let me run that again. And just one more time. What you'll see then is that each time we run the simulation, we get similar but actually quite different results, and the squares which remain uninfected are largely unpredictable.